I think everyone in the Agile world have heard. Most of you know the basic idea of behind continuous delivery. Even I had the basic idea of what it does. But to get into the deeper of continuous delivery ability, the concept, I just thought to create this video to help everyone understand what exact problem it solves and what exactly it is and how it can be brought to your organization, how you can implement, what are the key things needed to be able to bring in this concept into your organization. So this video, getting started from concept to reality, would help you understand and implement continuous delivery concept. So before I begin these steps and take you through the implementation process, I want to first hear you from something from you. Have your customer ever asked that, guys, we have a customer waiting and we need to get this bug as soon as into the production so that our customers can get immediately the solution and they can not get blocked. It is a very common scenario. But what happens is that in reality, though you have found the bug, you have fixed it, but to release it to the market, release it to the customer, it takes at least 1 month to 2 months. I don't know what organizations processes because of which even a small single line of code change, if you want to make it to production, you have to follow a long manual process of delivering to customer. Mary and Tom from Lean, they often ask this question: how long would it take your organization to deploy a change that involves just one single line of code? Just think about it. Try to analyze, try to see in your organization just as one single line of code. If you want to deploy that change, how much time it takes. Forget about the release to the customer. Let's say you want to get something up and running in a production kind of environment. Let's say we call it sandbox or UAT. But your developer says that my code is ready, but it is not in the integrated environment. It is in my local environment, so I cannot demo. And but your customer is very much looking forward to see each and everything up and running in one single integrated environment, so that he can quickly take the call of what can be taken, what can be taken to the market, what cannot. And most of these problems we hear because of manual intensive error prone risky process that we all follow. And believe me, continuous delivery is the solution to avoid such problems. Try to measure the cycle time in your organization. Cycle time is nothing but the time from deciding that you need to make a change to having it in production. That cycle time, try to measure it in your project and see how much time it takes to actually realize it into the production. If you really want to achieve a faster cycle time, a cycle time of hours or even minutes, you need to follow a fully automated, repeatable and reliable process to be able to go through various stages of build, deploy, test and release process. And everything can be possible if we try to automate each and every repetitive process. Automation is the key here, and we need to start thinking about what are the common manual tasks that we perform each and every day, which is delaying the whole process. Just try and automate each and every such manual task. Continuous delivery was the term was borrowed from the first principle of Agile Manifesto, which says our highest priority is to satisfy the customer through early and continuous delivery of valuable software. We are not agile, or we are not fully agile if we cannot satisfy the customer through early and continuous delivery of valuable software. So this concept of continuous delivery has to be brought in to the core of the organization to become fully agile. So what are the principles behind continuous delivery and why we should know these principles? We should know this principle so that before you try to bring in this concept or ability in your organization, you must know that these five principles should be in place. These five principles we should always follow. These are the thumb rules that we need to follow. First and foremost is the build quality in. We cannot inspect the quality at the end of everything is done. The quality has to be built in, as Dr. Deming mentioned in many of the articles. One example is you wait for the manual testing to happen to see the defects coming up in your project. Instead, why can't we just automate the test cases and get the defect as early as possible to avoid such quality issues? Second principle is work in small batches. We cannot try to check in large number of code, a, a large number change into the version control, and then get into the merge conflict issues and all everything. Rather, we try to see how far we can go with every small check-in we do. Can we take it to this release process in a in close to production kind of environment? Can we take this small check-in that we have done? That is the second principle. Third principle is people solve problems. Computer perform repetitive tasks. Understand that if you are putting people to solve or to perform repetitive tasks, there are high chances of errors coming into that particular task. Instead, let computer do those things. Do the automation of all those repetitive tasks that you do, and keep people to solve problems. Remember, I have heard from people saying that by automation you are actually going to make people jobless. That is not the reality. Instead, we are creating an environment where people can do much better creative work rather than the, the same repetitive tasks. Fourth principle is the continuous improvement. Relentlessly pursue continuous improvement. It should not be a one person's job to do the improvement. This has to be adopted by the entire organization. You should not be doing this improvement at one particular moment. It has to be a daily process. Everyone is responsible is the fifth principle of continuous delivery. We want to get or take feedbacks. We want to create a fast feedback loops from things that really matter. How customers react to what we build for them. Don't you want to know? Don't developers, product, program management team, everyone want to know what customer is saying which we have delivered to them? And that can only happen if everyone starts taking up in the delivery cycle. So this five principle has to be followed, has to be there in the organization to be able to build or bring in this ability concept in your organization. Now let's get into the implementation phase of continuous delivery. Continuous delivery relies on three foundations, the core foundations. First is the configuration management. Second is the continuous integration. And third is the continuous testing. Remember, configuration management is something that what we are saying here is if you want to achieve automation. See, in previous live I said that automation is the key. We want to automate each and every repetitive task what we see in releasing a particular software to the market. And if we want to achieve the automation, we need to version control each and everything required to perform repetitive manual process like build, deployment, regression testing, infrastructure provisioning process. Each and everything should be there in the version control. And why we need to do everything in the version control? So that we don't have to search for things in different places. We need to be very much sure what version is deployed in this environment, what version is there in that environment. It is very easy, it is very fast to be able to build, test, and immediately debug the issues that we have seen in the production or any environment. So control, the configuration management is a bigger concept that has to be there if you are following the continuous delivery. Second concept is the continuous integration. Continuous integration is something that will help your developers integrate their work into Trunk on a regular basis. There are many projects where number of components are involved, number of teams are working, but we cannot see as a whole a software because of the lack of continuous integration system in place. We can see the independent work going on in their in the team's work, in the team's environment, but in one continuous integration environment we cannot see. And this particular process, if we bring in, then we can actually start seeing software as a whole rather than bits and pieces. If implementing continuous integration is painful, then try to identify what is that painful task is. Bring that pain forward. Solve it. Work on it. As I mentioned, everyone is responsible in the continuous delivery. So everyone has to talk about that pain, talk about the issue. Third foundation layer of continuous delivery is the continuous testing. If everything is configuration management, if everything is integrated, then we need a system, we need system, people, everyone involved in that project to be able to do the continuous testing. The goal is not only to do the automation testing but also the manual testing. We want to know the behavior of the application. We want to know whether the security restrictions are being followed correctly in the application. We want to know if from the performance side we are all good. We want to know whether the application is really scalable. If we start trying to test with number of 100 users or 200 users at one time, we want to know each and everything, and this requires a lot of effort, and this has to be a continuous flow of testing rather than just doing testing at the end of the project. So remember these three foundations which you want to bring in, which you want to build before continuous delivery can be brought in your organization. Now let's talk about more in detail about the implementation. So I'll talk about the deployment pipeline. It is a pattern, it is a concept that has been brought in the continuous delivery model. If you read the continuous delivery book by the Jez Humble, you will understand in detail what he's trying to talk about deployment pipeline. He is basically talking about the stages of continuous delivery. You have number of stages to follow to be able to follow this pattern, to be able to follow this pipeline. What we are seeing a situation, a scenario, what we are trying to visualize a scenario is everything is automated. We have a 3 or 4 stages in the deployment pipeline, and at the click of a button, at the push of a button, any check-in of any change has gone to the production environment or in the UAT environment or in the capacity environment at the click of a button, and it's a seamless process. So we'll talk about these stages in more detail now. Stage 1, it is called commit stage. So as you have seen in this image, it talks about compile, commit, test, assemble, code analysis. So before we can actually try to see the behavior of the application and how it is working, the code level testing has to be performed by the application, by the continuous integration servers. The commit stage of the pipeline compiles the code, runs the unit test, performs code analysis, and create installers, or we call binaries. If the unit tests are all passed, code is up to scratch, we assemble the executable code into binaries and store them in an Artifactory repository. There are a number of tools available, and there are modern CI servers which provide such facility to do all these things. So we just have to make use of the technology, the tools, to be able to get through this stage, get through this commit stage. And the whole the goal of this commit stage is to be able to get the feedback on your code as early as possible. You want to start the process with the developers committing the changes into the version control system, and continuous integration management system responds to the commit by triggering a new instance of the pipeline and gives immediate feedback to the developer. So understand that developers will get to know immediately about the code that he has checked in into the system and will correct and respond immediately, rather than waiting for the manual testing to happen or some issue to come up. Let your unit test, your code analysis flow, your compilation issue get resolved first. And this is somewhere the continuous integration servers are of very much useful. If one person is checking in the code, then how the next person can check in, how the scheduling of the build can be done. Can multiple check-in happen at one time? If multiple check-in happens, then which check-in should be taken up first? Which check-in should be taken last? If one of the check-in breaks the stage, then who should take care of these things? So continuous integration system servers takes care of all these things. Jenkins is one of the famous tools that is followed or used in many organizations. So this is commit stage. Second stage is the acceptance stage. Once your code is clean, your code is ready to go into the next stage where we are going to understand the behavior of the application. This acceptance testing stage is the stage which is composed of longer running automation acceptance test. Automated acceptance test. Again, here we are not talking about the manual test case. We are talking about the automated acceptance test. So your CI server should let you split this test into test suites which can be executed in parallel to increase their speed and give you feedback faster, typically within an hour or two. Just imagine a situation where you checked in a code, your acceptance automated tests are running, and everyone gets to know the feedback, or that developer gets to know the feedback immediately. So this would help everyone, not only the developer but also the product or business guys, to understand at what level our project is in. At this point, the pipeline branches to enable independent deployment of your build to various environments. In this case, UAT, capacity testing, and production. Often you won't want these stages to be automatically triggered by the successful completion of your acceptance test stage. So you don't want basically to go into the production by automation test stage. Rather, you want some manual intervention in place in between. Your manual tester come into the picture, or operation team come into the picture, to be able to self-serve builds into the environment manually. So after the automated acceptance stage is over, the operations team or the particular environment owner can come and create build for their environment and deploy it in their environment to be able to test it manually or test some other functionality of the application. And to do this all these things, again, You don't have to rely on the manual tasks. You can use automated scripts that perform the deployment. Continuing the acceptance stage, the tester should be able to see the release candidate available to them as well as their status. So goal of the acceptance stage is the release candidate. Which version of the build is ready for the release? What is the stages? What is the status of that build? What were the check-in comments? Anyone comments on those and you can see anybody's comment on those builds. And if that release candidate looks good on a press of a button, you can select that build, and by running the deployment script, you can push it into a relevant environment wherever you want it. So this will be the closer of your stages of acceptance testing. And the final stage is nothing but your application is working from code side, application is behavioral way, it is working fine. Now you just have to follow the same principle and in the pipeline, and you just have to identify the environment where you want to deploy. And there are organizations where environments owners are different, so the owners of those environment can do the self-service deployment in by using this release candidate build that you have identified in the acceptance test phase. So this will complete the overall continuous delivery stages. Now this looks very straightforward, quite simple, but it requires a lot of effort. It requires a lot of inspection, and you need everybody's help and support to get things done. And you need to do a lot of automation. So that's where the right people are needed to be able to identify the manual task and to do the automation for each and every stages. So what are the practices we need to follow for deployment pipeline? Only build your binary once. Remember, the continuous delivery has a number of stages. You have commit stage, acceptance stage, then UAT and production stage, and capacity stage. But you don't want to build your binaries each and every stage. Rather, you just want to build your binary once, so that that version of the build you can verify in later stages of the continuous delivery cycle. Second principle or practice that we call is deploy the same way to every environment. It should not be a different way to deploy in different environment. You need to follow same model, same system setting to be able to deploy in different environment. And one way to do this is to use property file to hold configuration information. Use global property file, all these system settings, keep it there so that you don't have to follow a different model to deploy in different environment. Third practice is smoke test your deployments. After every deployment, there should be smoke tests that should be run, which will certify your deployment. And that is nothing but an automated script that does a smoke test. Again, it is automation script, automated tool. It is not a manual work here involved. Fourth practice is deploy into a copy of production. Don't deploy directly in production, but try to see which is a closely matching environment like production, and that will give you a good level of confidence that going live will actually work. You need to do your testing and continuous integration environment that are as similar as possible to your production environment. And fifth and sixth says that each change should propagate through the pipeline instantly. And sixth is if any part of the pipeline fails, stop the line and fix the problem. So it has to be a continuous flow. You find out the problem, you fix it, and again you run the stages and again reach as far as possible. So finally, I want to talk about some of the tools that you can think of to be able to succeed in the continuous delivery. There are tools like Nexus and Artifactory, which can help manage your artifacts. CI servers like Jenkins can help execute jobs in parallel on a build grid. So it is already being followed in a number of organizations. Then you can use practices as disk imaging and virtualization, and Puppet and Install Shield kind of tools along with the version control repository can manage your environment configuration seamlessly. All the contents in this slide are taken from the book Reliable Software Releases Through Build, Test and Deployment Automation from Jez Humble and David Farley. If you try to read this book, please go through once. This book has a lot of details about this continuous delivery practice. I will try to come up with a practical YouTube video to be able to show you how exactly this continuous delivery can be seen in the real environment. Thanks for watching this video. Hope this helps. Thank you.